What's up, guys? Let's take a look at another CodeWars exercise. This one's called What Century Is It? Short description, no big list of bullet points. We just say you get a year and you return what century that year is a part of. So 1999 is the 20th, 2011 is the 21st, and so on. We've got the amount of hundreds we've gone through plus 1. So like if the year was 41, we haven't completed a full 100 yet, but that's still the first century. So we have to add 1 somewhere along the way, and then we have to add the suffix of the th or st or whatever fits. The only one that seems tricky looking at these examples would be the ones right on the edge, because you don't start the next century until the 1. So 2000 is 20th, even though everything else that starts with 20 is 21st. And that's because we're starting the years at 1. We're not starting at 0, so you don't finish until you're about to do the next one. I'm going to open up some basic structure here. I'm going to open up with some basic structure to say what kinds of things are involved, and then we'll fill in the details. So I'm going to say century equals something. I know that step 1 will be to figure out the number of what century we're on. Remember, that's only the first half because we have to do the suffix. And we'll pretty much have to do them in that order because you use the century to find the suffix, I think. And then we're going to return them. I'm going to return an F string with those guys stuck together. And the nice thing about this is that it's nice and readable. The F string allows you to put names in there, and it also allows you to put different types. So century might be an integer, it might be a string, depending on how we do it, and yet this is able to print it without me doing int and str a million times. Ideally, we'll only have to do that one time, so let's try it here. At the beginning, our string comes to us, or our year comes to us in a string, and we'll probably have to turn it into an int to work with it. So that's ideally, if we can line it up, that'll be the only time we have to worry about types and int and string back and forth. I don't want to do that if I can avoid it. So the int year thing is going to give us a quantity of thousands, and we want to see how many hundreds there were. This is very similar to the change problem that we did months ago, where somebody pays $4 and it turned out to be $3.28, so you have to figure out how many quarters, how many dimes, whatever. This is finding out how many hundreds. So we go divide by 100 with a double slash to round down, only the whole number answers. And that's pretty good. Let's print it just to show. Let's print year and century just so we have it all in there. That's pretty good as a start because it gives us what would be the first 2 digits. And we need to do the add 1 thing, because 2154, that's the 22nd century, and 2259, that's the 23rd. So let's do, I can't say +1 yet, I have to put parentheses. But then when I start testing that, it's going to be right almost every time. Okay? It might not be right on those edges where it's like exactly 2000 or exactly 1900, but we'll save that for later because that's, I mean, literally 99% of the time that's not in the mix. So I'm happy with this century for the moment. We can always come back. And for the suffix, I kind of want to just test out if the whole thing is working. So let's just try what would happen if you just put th, and hey, that's the most common one, so we should get at least some of them right on the tests. Yeah, we passed 2. And in fact, I'm going to hit attempt and do the big test, which is a lot, because I bet we're going to pass like 100 at least. Yeah, we passed about half the tests just with a simple th, because that's the most common, right? First, second, third get other suffixes, but everything else gets a th. And even 1, 2, and 3 sometimes do if they're teens, right? Like you have 12 instead of 12 and so th is definitely the most common. And what I would love is the word unless. I would love to be able to say th unless something something. Now Python doesn't have that. I think the only language that does is Ruby, but we can do a similar idea. So what are our other things? Well, we have 1 goes to st, which is the case for 1 and also 21, 31, 51, etc. 2 goes to nd, and 3 goes to rd. Now that's a dictionary, and I could give it a name. I could call that like suffixes equals, but that feels misleading to me because that's not the suffixes, right? th is the most common of them, and it feels weird to say that that gets the name when it's only some of them. It also feels weird to add in every single other, like 4, 5, 6, 7, 8, 9, 0. That would also be annoying, so I'm not going to do that. What we can do, and what I've used in the past in different situations, but it applies to this one too, is a method called .get. Get says, well, let's look up what we're going for, and if it's not there, you give us a backup plan. So we're going to look up something we haven't decided yet, and then if it's not there, the th is the default, I think is what they call that parameter. So what are we looking up? We're looking up the last digit, which in the analogy of the change that I talked about earlier, that would be the pennies. That would be like just the very last ones. So I'm going to get that by saying century mod 10. The modulus is the leftover. It's the opposite of this double slash, which gives you the big chunks. This gives you the remainder, the pennies. So imagine we put that in here for the suffix. That would say, okay, look this up. If it's not in there, we use th. And that's going to pass hopefully more than 199, right? I'm going to attempt these tests, and it passed a lot more. We're moving in the right direction. I don't love the communication here because the .get method is supposed to mean it's usually in the dictionary, and then rarely we have a fallback. In this case, it's like usually not in the dictionary, and then th is the really common fallback, which feels off, but it is the way to do that. Like I said, I would love an unless, but we don't have an unless here. So we have 2 more cases to cover, one being the teens. We have to deal with 11, 12, and 13, and the other being the edge on a 0, 0, so 2000 or 1900 or whatever. I think the last one I mentioned is easier, which is we can just say -1. So if we take 1 off the year before anything, it will shift it just enough to give us the right answer. So like 2000, we go -1, that takes us to 1999, and that'll give us the answer. It won't affect any of the other ones because they would still have the same amount of hundreds. So if I hit attempt, we should get a bigger number than 264. Let's see. And yeah, in fact, we got a lot more. We covered almost everything. If you don't like that, I know it's pretty annoying to have a bunch of parentheses. You could also say +99 and then lose the 1, and would also lose a layer of parentheses. So you could say because the +1 at the end is like a whole dollar bill. It's like 100 in original points, and so if we take that -1 and the 100, we can simplified to a 99. I think this is nicer because it's shorter, but it might be less communicative. If somebody was reading the code and they saw -1 at the beginning and +1 at the end, they might get a better idea of what we're doing. Whereas if they see the 99, they'll have to slow down and think, what are you talking about? But I'm going to test this, just make sure I didn't mess it up. Let's make sure that it's still 354 after this change. And it is. So either way is fine. I kind of like either equally. And then we have to handle the teens. We have to say, the thing I've avoided so far is if, but I think it's a good spot to throw in it. If century is a teen or a tween, you know, the early ones, then suffix equals th. That would work, and that would pass all our tests. It feels a little off to do this and then undo it in the very next line some of the time, like we look up in the dictionary and then we throw it out. But of course, it is a rare case. It was only, what, 14 out of a couple hundred. And the other way to solve it would be to cram everything into one big expression for suffix, which I don't know if we like that or not. Let me show you what I was envisioning. We could say suffix equals th if that, else that, right? And then we'd get to, I like to indent these, I don't know if it matters. We'd get to something like our original vision, which had century equals, suffix equals, and return. And that would work, but of course this is very ugly now and hard to squish into a single line. It could be a single line, but it wouldn't even fit on the screen. So let's take a moment, look at solutions from others, and see if they found anything a little nicer. This says, hey, the first one, very similar to ours. I gave that a clever when I looked at it earlier, but it's really the same thing. They called it in instead of century, which is shorter but less descriptive, and they're doing exactly the same stuff. This one is the opposite. It's just actually saying if for every case. If we're in the 100s, if we're in the 200s, if we're in the 300s, etc. And I don't know if the person typed it by hand or maybe wrote code to write this code, but it's a little bit hard to imagine scaling that. Like, what if we had to do more centuries? Would you just make it even more lines? I don't know. This one is great. We have the ins with method, which is very readable, and then we have the exception for the tweens right in here, so we never have to like undo our work after fixing it once. I usually don't like having multiple returns. I like to lead to one specific point, but when they're like this, it's very easy to see. You won't forget about other ones because it's all in your eye line at the same time. The next one is kind of nice because they squeeze the exceptions into the dictionary, so it feels unified, feels like one thing, but then they have to do this, looking it up to say, okay, if the 2-digit version is in there, we do one thing, otherwise we look up the 1-digit version. And that is a little annoying to write if, else, in, and in a bunch of times. But I do love their final line, which is set them up, return, beautiful. And if you keep scrolling, you'll see variations on these. Eventually, I'm sure we'd find one that blows us away. But the general idea is get the hundreds, use them to find the suffix, and then put them together. You can get the hundreds by dividing. You could also get it by turning it into a string and taking a slice, but that's a little tougher. And then to get the suffix, you could use match case, you could use if else, you could use a dictionary, and eventually find the same answer. So I thought that was a good one, and next we're actually going to look at some similar problems that will hopefully get the pattern ingrained into your mind.